Assalamualaikum and good morning. My name is Muhammad Zafar Aziz bin Wasaimi. I'm the representative of the Group 9 of the subject Statistic, Engineering Statistic. So, without further ado, I'm going to explain about the demonstration on the Excel. So, I want to introduce my four kind of data, which is the first one is the regression data row, the second one is the regression, and the third one is the Pearson correlation, and the last one is the QQ plot. So, I'm going to explain about the data row first. So, we must obtain two kind of data, which is the first one is the independent, and the second one is the dependent. So, independent affects the dependent variable because when the independent variable, you get different value, such as for our case, is temperature. So, when the temperature goes high, for the outcomes, the electricity demand become less than compared to the temperature when it go lesser. So when the temperature goes down, so the electricity demand goes up because the residential or the industrial sites use much more electricity because they use heater in order to keep the body getting warm. So, uh, so only this data, uh, I already developed three kind of data besides of the independent dependent variable. So we must get the regression graph, the predictable versus the standardized value, and also the temperature in Celsius divided by versus with the standardized value. In order to get all this value, we must use the certain formula. So the first one, you must using this formula. You can see on the formula bar. So the second one is the residual. So in order to obtain the residuals value, you must subtract value between the electricity demand and also the predictable value. So this is our residual value. So I'm going to I forgot these two kind of data, which is the mean and the variance. So we use this formula to get the mean, and this one for the variance. You can see at the formula bar. Same goes towards to the electricity demand. So in order to get one addition info, in order to get the slope, we must use the formula of the slope, but uh, you can see on the formula bar, I set it the range from the y-axis, the total of the y-axis uh, from the top until the bottom, divided by the value of the x. So you can get the formula of the slope, which is the mx, the gradient. And the y-intercept, we just use the formula of the intercept. Same goes towards the slope. We use the data from the top to the bottom. So this is the graph. In order to get this graph, you can just straightly forward, just drag uh, the data above, and then you just press the control key, and then you just, for example, I'm going to show the printable. Just a demo. So you must go to these charts and then just scatter. So this is our value. So in order to get the precise value, redo the axis, and also you can edit the axis on the y also. So For the second one is the data itself. So how do we get all this data? Uh, it is simple by using additional function in the Excel, which is the data analysis. You just can straightforward. You can just straightforward selecting these two data, and then you go to the data, and then the data analysis, and then split the regression. Then set OK, and then you can tick the labels and also the confidence level. So why the 95%? Because our alpha is 5%. So in order to get all this value, such as this one, the regression data, we just can tick on the residual and then standardize. Then you click OK. You can just split. Then you can sorry. Then you click OK. So this is the exactly as shown in the previous data, but this is the one that I already finished. The similar one. You can get all the value from the multiple regression statistic, which is the multiple R square, and all the additives. So going to back for the data row first, uh, you can see that our regression line is occur among the data itself by comparing those two value, which is the first one is the electricity demand, which is the Y value, and also the temperature, which is the S axis. So you can see this graph is kindly show negative relationship because it tends to go downwards from the bottom until the from the top until the bottom. So this is our R square value. You can compare this value with the previous regression data. You can see at the intercept point, you can get the value of the 666, and also the M value is negative 1326, approximately about negative 1327. You can see uh, similar one. So the results to conclude that uh, our formula is similar to the Excel formula. So without further ado, I'm going to explain about the Pearson one. So the Pearson one, it just goes straightforward by using the formula on the slide itself. So we use the original data, and then we use the function formula of the correlation, which is the x times y, x square, y square, in order to obtain SSY at SSS, SYY, beta 1, beta naught, SSE, R square, and R. So in order to get the value of the SY, we just times up A S times Y, and the S square just multiply it with the square. Also, same goes forward. Same goes to the Y square. So in order to get the value of the SSY, we use the first formula based on the formula given on the slides, which is the total of the SY minus with the 1 over n. Our n is 36 and then multiplied with the total of the s and also multiply with the total of the uh, multiply with the total of the electricity demand. So we get that the value of negative 932.627. So I'm not going to explain the other formula. You can see in the formula bar. You can see it. This one just uh, the SSY divided by SSS in order to get the beta 1. This one is the B naught. You can see it. And then just simple formula. So what can I calculate on this calculation correlation? You can see that the uh, alpha, beta 1 and beta naught is similar because uh, in the slides, it states that the value of the y is equal to the b naught b1 plus b naught equal to y. So you can see that the beta 1 is represent the value of the m and the beta naught represent the value of the c. So there's nothing much to say about the Pearson one. Going to the last one, which is the QQ plot. So why I use the standard residual? Because our finalized answer for the regression data is the standard residual. So I'm going to use the standard residual data and then ranking them from the bottom until the top value, and then calculate the percentile and also calculate the normal theoretical quantile, and lastly the data quantiles in order to get this graph. So we use this formula to get uh, the the ranking order, which is the Excel will conclude the ranking from the erase the value of the less the bottom value to in the ascending order to the top value. So